Okay, chemistry students, so here we go with lesson 7.2. We're going to look at converting masses of substances to moles and moles back to masses. So the objectives are for you to determine the number of moles of a substance from its mass and chemical formula, or given the number of moles of a substance, determine the mass of the substance. Again, you would need to know its chemical formula. So we're going to put together the mole idea with the molar mass and learn to go back and forth. Let's get started. So remember way back to the first marking period we taught you how to convert like metric units and things like that. So let's do a brief review of conversion factors.
So first of all, a conversion factor is a fraction with a value equal to 1. Granted, the two numbers, when you divide them, may not equal out to 1, but they are things that are equivalent to one another.
12 inches is the same as 1 foot.
Exactly, or there are 100 centimeters in a meter. Those are equivalent things that all equal the same thing. So let's do a quick conversion using the fence post method. Let's say we want to go from, I don't know, 5 centimeters to just do plain old meters.
Equals some number of meters. Okay, yeah. So we're going to say how many meters is in 5 centimeters. Okay. Now we need, this is our equivalence relationship we're drawing on here is the fact that 100 centimeters equals 1 meter. So from that we can build two conversion factors. We can write the fraction 1 meter over the denominator of 100 centimeters. That's a conversion factor. It's equal to 1. Or we could also say that 100 centimeters is the same as 1 meter. So we just need to choose the conversion factor that's going to get us to the desired end unit and cancel out the unit we don't want. So we want to put the one that has the 1 meter on top and the 100 centimeters in the denominator. And the fence post method allows us to cancel the units, so we end up at the unit we want. We take 5 divided by 100, 0.05 meters is the answer.
And for those of you, in my class, I don't write it like this. I write it like 5 centimeters. That was a horrible centimeter. The actual fence post, and then you'd put the 100 centimeters and 1 meter like that. So that's,
but it's really just two different ways to show the same thing.
So this method here is literally the fence post. This method is more
dimensional analysis.
Yeah.
I think it's called. It's the
same difference.
Same thing.
Just I wanted to show you both ways before we moved on, so you wouldn't be confused if you saw me doing it or Mr. Ferguson, since apparently we both do slightly different.
And the point is that we can use, this is a powerful tool that we use in chemistry, and especially in these mole problems, we're going to be changing from one thing to another using the conversion factor that we derive from the equivalence relationship.
All right, so this is our first example of this new type of conversion that we're doing. The molar masses, of course, are an equivalence relationship. So if we have 56.7 grams of water, we need to know how many moles or how many grams there are in 1 mole of water. So if you look at a periodic table, you know water is H2O, and each hydrogen is 1, oxygen is basically 16. So you're looking at a relationship that has 18 grams of water per mole.
So another way to say that is that 18 grams of water is equivalent to 1 mole of water. And that's our starting point. So we have to recognize that there's the equivalence. Once we have an equivalence that has grams and moles, we can change back and forth from one to the other.
Especially since the question wants to know the number of moles in this many grams. So much like any other conversion, we start by writing down the given value, which is 56.7 grams.
And now, how many moles equals 56?
I've started to skip this step.
0.7 grams. And then I'll use the Mr. Hunter method, so we'll go like this.
Don't forget to put your unit now. It's not just grams, it's also grams
of water.
That is an important factor to keep a tabs
right, especially
on
when we
now.
get into chemical equations where you got 4 different substances, you got to specify.
So on tests or quizzes, we'll need to see units and the actual molecule it is. So in 56 grams, we know that there are 18 grams per 1 mole.
So I'm going to put the 18 grams down here and the 1 mole on the top of my fraction.
And again, you would have to label them with H2O because
very
few molecules would have 18 grams as their molecular weight, but still, it matters. So right there we go. We take 56.7 times 1 divided by 18, and we get 3.15.
3.15. Notice how you kept the same number of significant digits.
Exactly. Now you do, because this number up there, 56.7, is a measurement, so it needs...
So this has 3 significant figures, so we're going to keep 3 in our answer. The molar mass is considered to be a given value,
yep.
so there's how you do it. So it's really the same, applying the same method we use for metric conversions to a new situation.
But now if you forget how to convert, we have this mole map or mole island map. It's basically in the front cover of your packet here. If you're going from mass to moles, it tells you 1 mole is equal to the molar mass in grams, or vice versa. You can go that way. So it kind of gives you a roadmap for solving. All right.
So here we have a second example. We're going to take it the other way. We're asking you to determine the mass in 3.42 moles of magnesium chloride. Uh-oh, Mr. Hunter. It doesn't tell us the chemical formula.
Exactly. So once again, if you can't name, you're not going to be able to succeed here. But for simplicity's sake, magnesium chloride is MgCl2, because magnesium's +2, chloride's -1, so magnesium chloride. The formula, or the molecular, I guess it's formula mass, in this case, is 95.21 grams.
95.21 grams.
And you get that from the periodic table.
Cl2.
And that's equal to 1 mole.
Equals 1 mole.
Now again, we set up the fence post given first. So it's going to be 3.42 moles.
All right, we'll
of course,
use your
MgCl2. And then at the bottom there, you have to have it so your moles cancel. So 1 mole on the bottom of MgCl2.
95.21 grams. MgCl2. The moles are going to divide out.
And then your calculator would tell you an answer of 325.618 grams. But of course, we have to keep the same number of sig figs. Our original number has 3. So our final answer also has to have 3. So it's going to be 326 grams of magnesium chloride. There you have it. And our last example, they want to know a chemist needs to measure out 0.614 moles of silver nitrate. How many grams does she need to measure? So again, you have to be able to know silver nitrate. Silver is a +1, nitrate is a -1, so it's going to turn out to be AgNO3 in the end. The molar mass for this is 169.87 grams per 1 mole.
All right, so we get started. So we're going to use my method here now,
Sure.
which is the same thing. How many grams are we going to need to get 0.614 moles of AgNO3? Okay, so we're going to install the correct conversion factor here. So we've got moles, so we want to put our 1 mole on the bottom of AgNO3, and the equivalent number of grams to a mole, which is 169.87 grams for silver nitrate. Moles cancels out.
You hit the calculator, it tells you your answer is 104.300.
Of course, we know we're basing it on how good the original measurement was. So we're going to round that to 104 grams of AgNO3, silver nitrate.
And that's the end of this part of the conversions. Of course, there are several others, especially when we get to the next unit, but it's a never-ending stoichiometry challenge now.
But you know, if you can recognize you've got the equivalence relationship, build the conversion factor to get to the unit you want to. They all end up working out very similar. You just need to know the conversion facts, the equivalence relationship. So we'll continue the next lesson with the next part of the mole island diagram.
I think it is moles to
particles. Yep.
All right. Have a good night.
All right, students, now that we've gotten the lesson on mass to mole conversions, we have 2 post-video questions for you to try out on your own. First one, what's the mass of 0.85 moles of NaCl? That would be sodium chloride. And then the second one's the reverse. How many moles would you have if you had 100.0 grams of MgCl2? So give those a try, and we'll discuss them in class next time.